All right, in this video, we are going to be talking about transformations of graphs, their domain and range, how to graph them, and then we'll pick apart um, their shifts as well. I will only do the odd ones. That way you can practice with some of the even ones, and we'll just go from there. All right, so let's take a look at number one. So first off, I do recommend us starting with the parent graph or your parent function. So the parent function just meaning, hey, what did we do to your graph? What did your graph originally look like before any sort of transformations came on? Now, to recognize that, notice that we're trying to strip away the bare bones to it. So taking away this 4 and this -2, we're then just left with x squared. So our x squared graph should look something like this. And you really just need 3 points, 3 features on here to graph it as best as possible. So if this is your original f of x graph, or maybe we call it something else, maybe this is p of x, maybe p is parent. So then let's look at your transformations. So if we have numbers located on the inside of any sort of grouping, notice that grouping being your parentheses, it could be absolute value signs, it could be square root signs, anything that lumps it together close to your x value will shift your graph left and right. So if it looks like we have a -2, we're going to be doing the opposite. Instead of your negatives being on the right-hand side, the opposite is that we're actually going to be shifting to the right. Oops, my apologies. To the right by 2. And you can think about this as well as setting it equal to 0. So adding 2 to the same side. So x having equal to +2. Well, +2 is to the right. So we're going to shift right by 2. So if it's on the inside of these groupings, you want to do the opposite action. So if it's subtraction, we're going to get more positive. If it's adding, we're going to get more negative. Whereas if you have numbers on the outside, like this 4, this is going to be shifting your graph up and down. Now, unlike your x value, when we go to shift up and down, we're actually just going to take your side and do what it says. So y values are straightforward. So if it says +4, we're going to go up 4. If we wanted to go down by 4, it would be negative. So y values, we're going to keep the sign, right? X values, we're going to change your sign. So we are taking your 3 points here and we are going to shift them right by 2. So taking this point here, we're going to shift it right to 1, 2. We're going to then go up by 4. 1, 2, 3, 4. So this is where your new vertex will lie. And then the other points as well, you're going to shift it over to 1, 2, and up by 4. 1, 2, 3, 4. So that's your other point. And you're going to do the same thing for the other next point. And you can do this for 3 points, for 5 points, however many you would like. You could also go ahead and pick some x values, but you really want to make sure that you pick your vertex, which sometimes it's hard to locate right off the bat because nice points that we want to plot typically are -1, 0, and 1, which will then miss altogether your vertex. So we definitely want to come into the idea of graphing with what does this graph look like originally? What does the parent graph look like? And then use your shifts. Now your domain for all of your parabolas, because they have this U shape, there's no x value that is off limits. So we're going to be going from -infinity to infinity. Because while your graph is going up, it's actually going out. So starting from -infinity and coming all the way down to your vertex. And then while your graph is going up, we're still going out towards +infinity. Whereas your range, we read from bottom to top. So your smallest x or your smallest y value here happens to be at your vertex. Your vertex being at 2, 4. So your smallest y is 4, and your graph then continues to go up. So we're going to include your 4. We have a solid dot at 4 and go up towards +infinity. Let's try it again with 3. And I'm noticing that the odd ones, they don't have any sort of reflections. So I might change it up as to which ones I'm doing. Maybe I might actually just do the first 3. And then I would recommend you guys doing maybe the next 3. All right, so here, again, what is your parent graph, your original function? Well, if we take array everything, we just really strip it down to what it used to be. We're going to take away this x, take away any sort of number, and take away this negative. So anything that is not attached to your x value, we're just going to take away. So we have x cubed. Now an x cubed graph, if we were just to graph 3 points, would look like this. Now I do recommend rewatching the video, what is it, 3.4, to get an idea of what all of these parent graphs look like. It'll go a long way when we go to do these transformations, because otherwise you're going to have to remember how to graph these other ones. So these are your 3 key points that we are then going to move. So we said, hey, the values that are located on the inside of any sort of grouping, right? If it's a -3, we want to switch your negative to a positive. So really +3, which that is going to be over here. So we're going to shift your graph 3 to the right. So that is what this means. Shift 3 to the right. And then this minus sign over here says we are going to shift, and we're going to keep the negative. So the negative ones are over here. So we're going to go down by 1. And then something new is this negative here. When it's a negative on the outside of your grouping, in other words, it's not directly attached to this x value, we are going to be reflecting over the x axis. So reflecting over the x-axis is probably something that you want to do first. So that just means if this is the x-axis here, all of your y values are then going to flip-flop. So that just means this point comes down here and that one goes up here. And your origin point stays as is. Anything that's on the origin will then just stay put. So your new graph right now is just going to go through this flip. Now then we're going to shift each point to the right by 3 and shift down 1. So right 3, 1, 2, 3, and down 1. So that's your new point. Shift the right 3, 1, 2, 3, down 1, and one more time. So your new graph should be this one in blue. Now both for your domain and range, there are no points that are off limits, and they are both going to be going towards infinity. And that's going to be true for all cubes, for your graphs, as long as there's no holes or jumps and things like that. Now let's talk about number 3. So your grouping is going to be this square root. So take away any of your values, you're just left with the square root of x. Now how that looks is this. Let's see, 4, we're all the way up at 2. So we just need 3 points to give us a good idea as to what this graph used to look like. And so if we have a +1, we want to say it's the opposite, so really a -1. So we shift this graph towards the left side, negative. Shift left by 1. And we have a +4 on the outside, which means we're going to be shifting up by 4. So take each of these points and we're going to shift it left 1 and up 4. 1, 2, 3, 4. So that's your new point here. Shift left and up 4. Shift left 1 and up 4. Right there. So that's your new graph. And let's talk about your range. So where do your x values start? Well, they start here at -1, and we're going all the way towards positive infinity. So your domain here, -1 to infinity. We can be equal to a 0 underneath a square root because the square root of 0 is just 0 plus 4. So that's okay. That's why we definitely want to get your key points here from your parent graph to then do the shift, because if we just start plugging and going and we ask about the domain, it's a lot harder to understand what your domain looks like. With your range, right, you're starting at your smallest y value. In our case, your y value is 4. And while we're going out, your values are also going to be going up. So we're going to have 4 comma infinity here. All right, let's try it again. And I'm going to do the ones on the next page. All right, just by looking at it, I might try these bottom 3. So that means you guys can try the top few. So number 10, we're going to be taking away all of these numbers, and we're just left with the cubed root of x. So let's say p of x, your parent graph, is perhaps the cubed root of x. So to get your first 3 points, it would be these 3. And again, please watch the video for how these graphs appear. So definitely go back and watch 3.4, where we talk about just other graphs. So this is what the cubed root looks like. And now we're going to take anything on the inside grouping, which shifts left and right. If it's +2, it's really going to be a -2. So -2 being over here, we're going to shift to the left by 2. And then we have this 4 on the outside. So shifting it down by 4. So we take the sign, so down 4. So we shift left 2, 1, 2, down 4, 1, 2, 3, 4, and do it for, all of your points, keeping the same sort of shape. So we're getting nice and long. That should be your equation. As far as your domain goes, with your domain for any sort of cubed root, there's no x that is off limits, because you'll notice that we both have negative x values and positive x values here. There's no holes to think of. So we're going to be all reals. Your range, while it is going out, it will still continue to go up, but it's just going to take a little bit longer to reach higher y values. So the same thing. As far as 11 goes, we haven't done an absolute value graph, which again, take away all of your numbers and any sort of negative on the outside. You're just left with the absolute value of x, which its graph is the one that looks like a V. So looking like this. This is a parent graph. So let's see what shifts we have. We have the -7 on the outside, which we're going to shift down by 7. The +2 on the inside, which means we're going to go left by 2. And the negative also found on the outside is going to be a reflection over the x-axis. So again, I do suggest doing the reflection first. So with that reflection, your values are just going to get mirrored over the x-axis. So this is what we should look like. Still keeping with this idea of the graph. So this is what your graph now looks like. Then we can go ahead and start to do your other shifts. So shift left 2 and down 7. 1, 2, down 7, all the way right here. Your new graph looks like this. Let me try that again. Okay. So what is your domain here? Well, as far as your x values are concerned, right? We have both, you have your graph starting down low, but as you're getting lower and lower, your x values are getting lower as well. So we're going from -infinity. And as we approach this turning point here, Again, while we continue to get lower on the other side, we're still going to be going out. So your domain is all real numbers. For your range, we read from bottom to top. So your smallest y values, while they are nice and small down here, so we're going to start at negative infinity. And as you go towards the top, your highest y value happens to be this turning point here. Your turning point being where your y is now -7. So you're going from negative infinity to -7. And we're on -7. So we stop at -7. And you'll notice that any sort of infinity we have, we're never going to include that value because it's not achievable. Lastly, we have an exponential function. Now, again, just take away all of the numerical values. Now, this too, as much as you're tempted to probably cancel it out, this is actually your base. So when you strip away everything, your parent function is really 2 to the x. Now, what that looks like, probably something like this. We'll get lower here. We're going to go up high, actually. Let me do that one more time. Get low. Go up high. There we go. Now, if you're confused as to how to graph this one as well, because we haven't done this one, or we won't do this one until we hit the exponential section, which is in chapter 6, you can start to graph, okay, well, what happens when x is 0, we're equal to 1, x is, oh, and there we go, there's my mistake. When x is 2, when x is 1, your y value is 2. When x is 2, your y value is 4. So we're going to be going up like that. And then same thing when you're approaching a smaller value. So this is what your parent graph should look like. And then we're still sticking with all of the shifts. We're going to increase all of them. We're going to go up by 2. And then this value here, it looks like we're -3. So getting to +3, we have to go to the right by 3. So we're not going to be changing the process just because we have a base value of 2. We said shift up 3, nope, shift up 2 and right 3. So each point, let's see, shift 1, 2, 3 and up 2, 1, 2, that's 1, 1, 2, 3, up 2, 1, 2. And if we wanted to do another 1, 2, 3, up 2, 1, 2, maybe down here. So this is what your graph looks like. And before I continue my graph, there is some key feature I should be aware of, and that is going to be my asymptote. Now, your asymptote here is at y is equal to 0. Now, while you're moving your x values, there won't be any shift if we're just moving your x values to the left and to the right, or if we just mirror it. But the second we transition your graph to move up or down, this asymptote will continue with us. So if we have a shift up by 2, then we're going to be shifting this up by 2 as well. So your new asymptote should be shifted up by 2, 1, 2, right here. So this is where the new asymptote would lie at y is equal to 2. So when we finish your graph, we don't want to touch that red dotted line. So this is what your graph should look like. Now, why that is important is it comes into your range, because as your y values, right, we want to get as small as you can, right, we're going to be starting to approach this 2 mark. So your range, we're going to be going towards 2, but we can't be 2. So we're approaching 2. And then your y values, as your x values increase, your y values will also increase. Now we cannot be 2 here. We can be as close to 2 as possible. So do not touch 2. And as far as your x values are concerned, as your y value is trying to get as close as it can to 2, your x values are just going to get further out. So we'll be doing all real numbers there. So that is how we can tackle these ones. There aren't a whole lot where we have a y um, a y-axis reflection. Now, what would that look like is that if you had a negative directly on the inside of any sort of grouping here, that would be you're reflecting over your y. To see it on here, it would be attached directly to this x. And that's it.